All right, this is exam 1 from Physics 102, spring 2013. Metallic object holds this charge. What is the total number of electrons? So we just say 3.8 times 10 to the minus 6 coulombs. And then one electron has 1.6 times 10 to the minus 19 coulombs. And that gives you 2.4 times 10 to the 13th in electrons. So that is B. Number 1 is B. Which of the following best characterizes electrical insulators? They have a high tensile strength. That might be true, but not necessarily. Electric charges move freely within the material. That's for conductors, so that's not true. They are good heat conductors. Maybe, though most likely not. Usually not. Charges in the material don't move. Okay, that's electrical insulator. 2-point charges are 4 centimeters apart, and then they're moved to a new separation of 2 centimeters apart. By what factor does the resulting mutual force between them change? Well, F is K, Q over R squared. I'm halving that distance, so I get a factor of 4 for the force. So number 3 is C. Thundercloud, there may be an electrical charge of 40 coulombs near the top of the cloud. So here's my cloud. I have 40 coulombs, negative 40 coulombs at the bottom of the cloud, and they're separated by a distance of about 2 kilometers. I want to know what is the force between those two sets of charges. But the force is K, Q over R squared. That's 9 times 10 to the 9th. 40 coulombs, divided by 2 kilometers squared. That's 2,000 meters squared. Okay, 3.6 times 10 to the 6, so it's C for number 4. Electrical field is dimensionally equivalent to which of the following? The units are newtons per coulombs. So number 5 is C. Charges are placed at the corners of this right triangle. What is the magnitude of the electric field felt by the 2 microcoulomb charge? So I want to know the magnitude of the electric field at that point. It points up in this direction, though we don't need that right now. The electric field at that point is equal to KQ over R squared. The electric field is due to this 4 microcoulomb charge, so that's 9 times 10 to the 9th, times 4 times 10 to the minus 6 coulombs, divided by the distance. This is a 3, 4, 5 triangle. That's the square root of 3 squared plus 4 squared is equal to 5. So it's over 5 meters squared. That gives me 1.4 times 10 to the 3rd. That's 1,400 newtons per meter. Now I also want to know in the next question, what's the direction of the electric field? I've already drawn the vector here. I want to know this angle. That angle is the same as this angle. So I can find that angle. The inverse tangent of 3 over 4, that's opposite over adjacent, 3 over 4. 37 degrees. So this angle is equal to 37 degrees. Means this angle is also equal to 37 degrees. Let's see what the options are. I have 37 degrees below the positive x-axis, but that's not true. It's not that. It's not that. It's this. 37 above the negative x-axis. So number 7 is D. This figure shows 2 charges in their electric field lines. A charge on the right has a magnitude of 10. So this charge is plus 10 microcoulombs. What's the magnitude and sign of the charge on the left? Well, I know it has to be negative, so I'm just going to go and get rid of all of these 2 answers. I count the field lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 field lines. 10, 2, 3, 4. All right, so that means that I have 4 microcoulombs over here, and it's negative. So D is the answer. Or 8 is D. Consider this configuration of charges. Which vector best represents the net force acting on this charge? All right, well, due to this charge, I get a force that's in this direction. Due to this charge, I get a force that's twice as big and in this direction. So my net force it's going to be like that. That's B. For number 9 is B. Proton accelerated in a constant electric field. What is the velocity? All right, I know F equals QE, so I can find the force. Times 220. That's 3.5 times 10 to the minus 17. It's in newtons. Now I want to find the acceleration. Newton's second law. That's the force, which is right here, divided by the mass, 1.67 times 10 to the minus 27. Right, yeah, this is a proton. That's 2.1 times 10 to the 10th meters per second squared. And then I want to know the velocity, v naught plus at. It says it's at rest initially. So I multiply this times the time, which is 1 times 10 to the minus 6. 2.1 times 10 to the 4th. That's A for 10. Capacitor consists of two metal plates. There's the area, the distance between them, has a dielectric. What is the capacitance of the capacitor? Well, C is equal to kappa epsilon naught A over D. That's 1.8 dielectric. 8.85 times 10 to the minus 12. That's on your equation sheet. Permittivity of free space. Area is 0.3 right here. Divided by 1 times 10 to the minus 6, separated by a micron. And I get 4.8 times 10 to the minus 6 farads. That's 4.8 microfarads. Would be D for number 11. What is the equivalent capacitance of this circuit? All right, I want to do these two first. 1 over a half plus a half is equal to 1. So I can replace these two with a 1 microfarad capacitor, which I'll then combine with this 1 microfarad. 1 plus 1 equals 2. So the answer is A for number 12. What is the charge on the left 2 microfarad capacitor? All right, I know that I have 12 volts here, and I have 12 volts on these two capacitors because they're in parallel with this 1 microfarad capacitor. So that means that I have 6 volts across each of these, and my charge is C times V. So that's 2 microfarads times 6 volts, which is 12 microcoulombs. So that's A for number 13. Two charges arranged on the vertices of this triangle as shown. What is the potential at the top of the triangle? So here I have 10 microcoulombs and negative 6 microcoulombs. I want to know what is the potential up here. V is KQ over R. The sum, that's going to be 9 times 10 to the 9th times Q, which is 10 times 10 to the minus 6 over 1 meter plus 9 times 10 to the 9th times negative 6 times 10 to the minus 6 over 1 meter. I can simplify this. It's going to be factor out some things. 9 times 10 to the 9th times 4 times 10 to the minus 6. That's just the sum of these two numbers divided by 1. I'll just leave that out. I get 36,000. C. And then I want to know, what if I bring in a charge from very far away to the place at the top of the triangle? All right, my change in potential will be 36,000. All right, and my work done to bring that charge in is going to be Q times delta V. That's going to be 2 times 10 to the minus 6 coulombs times 36,000, which is 0.072. That is B for number 15. So to the circuit, all the capacitors are identical. What is the voltage across C1? So I can redraw this. I have C1, and then I have 2C. Because they're identical, I just add these two to get a capacitor of 2C. I have 12 volts. All right, we had a problem like this in class. So I have a capacitor and then a capacitor that's twice that value. So that means that one of them is going to have 8 volts, and one of them have to be 4 volts. Because one of them has to have a voltage that's twice the other, and they have to add up to equal 12. The smaller capacitor has the bigger voltage. The bigger capacitor has the smaller voltage. Remember, this is Q is equal to CV. So if C is big, that means the voltage has to be small. So I was looking at C1, that's 8 volts. D, 16. This diagram shows collection of charges. Where is the potential 0? Take each point. The potential, the distance from here to here is not the same, so those potentials don't cancel out. How about right here? The distance from there is the same as the distance to there. There to there is the same, so those potentials cancel. And there are the same. So B is the right answer, but let's just look at these others. For C right here, this distance is not the same as that distance, so those potentials don't cancel. Here, similarly, this distance is not the same as that distance. Likewise, this and this are different distances. And here, in a similar way, this distance is different from that distance. So what was it? B is the only one. The potential is greater closer to the charge. V is KQ over R. If R is small, V is big. So A is 18. What is the equivalent capacitance of this circuit? If I combine these two, 1 over 4 plus 1 over 4, that's equal to 1 over a half, which is 2 microfarads. And then I combine that with this one, and that gives me 2 plus 4 equals 6 microfarads. And so I'm left with a circuit. I have a 6, a 6, 1 over 6 plus 1 over 6. It's 1 over 2 6, 1 over a third. So it's equal to 3 microfarads. So number 19 is D. Two pieces of copper wire, the same diameter. So they're also copper, so they have the same resistivity. The length of wire A is twice that of wire B. A longer wire has a bigger resistance. If it's twice the length, it's twice the resistance. So the answer is D. For number 20, the resistance of wire A is twice that of wire B. This is A. This is B. Consider the circuit. What is the current through the resistor? Well, I from Ohm's law is V over R. That's just 12 over 3. It's 4 amps. We apply a potential of 3 volts to a particular electrical device. The current is 2 amps. When you apply 6 volts, the current is 4 amps. All right, so the resistance for the first one is 3 over 2. 3 volts over 2 amps equals 1.5. And the resistance for the second one is 6 over 4. That's also 1.5. So this is an ohmic device. It obeys Ohm's law. So these has a greater current. All right, P is equal to VI. V is constant. If P is big, that means I is big. So that would be the bathroom heater. 50 ohm resistor is hooked up to a power supply of 150 volts. What is the power dissipated across the resistor? P is equal to V squared over R. 150 volts squared over 50 ohms. It's 450 watts. Excuse me, 24 is B. 450.